So today we're going to talk about two-step equations. Two-step equations are essentially problems that we're going to have to do two steps to find our answer. They're going to be set up in a format similar to this. In this case, x is our variable. In these equations, to solve them, we need to get x by itself to find out what x is equal to. And again, these require two steps generally. First, I would try and isolate x with its coefficient. What I mean by that is if you have x times something and then plus or minus just a number, I want to get this number combined with that other number, so I just have this part alone. So for example, I want to get rid of that plus 2. I'm going to subtract 2. I'm going to apply the opposite of addition using subtraction. Now, because this is an equation that's equal, to keep it balanced, if I subtract 2 from this side of the equals, I have to subtract 2 on the other side of the equals. We have to keep these equations balanced as we work through those. Now 5x is just going to come straight on down. 2 minus 2 is 0, so I'm not even going to bring anything down there. I'm just going to bring down the equals. 17 minus 2 is going to be 15. Now there's no sign or anything between this x and this 5, so we know that it means it's being multiplied. So in this step, if I want to undo multiplication, because remember, I'm trying to get x by itself. I want to undo multiplication, I need to use division. So I'm going to divide this side by 5. And again, to keep this balanced, we have to do the same thing to the other side. 5 divided by 5 is going to be 1. 1 times x is just going to give us x. Okay. 15 divided by 5 is going to give us 3. Our answer is 3. Again, if I plug this back in here, 3 times 5 would be 15. Plus 2 would give us 17. It checks out. So let's just do a couple more examples. So this first example up here, we have negative 4x minus 2 equals 6. I'm going to go about this the same way I did the last one. I'm going to get rid of addition or subtraction before I get rid of this multiplication. So to undo subtraction of 2, I'm going to add 2 again. Got to do it to both sides of the equation. Negative 4x is just going to come straight on down. Negative 2 plus 2 is going to cancel out. Bring down this equals. 6 plus 2 is going to give us 8. Okay. Now in this case, you got to keep track of this negative here. So I'm not going to divide by 4. I'm going to divide by negative 4 because I want this to become just x. So I need to divide by negative 4, that whole coefficient. Again, if I do something to one side of the equation, I have to do it to the other. Negative 4 divided by negative 4 is just going to be 1. 1 times x is just going to be x. On the other side, 8 divided by negative 4. Well, 8 divided by 4 is going to be 2. If you take a positive, divide it by a negative, your answer is going to be negative. So in this one, our answer, x equals negative 2. Again, negative 2 times negative 4 would give us positive 8. 8 minus 2 would be 6. It checks out. Let's do this one last example here. Just going to keep following through, same steps I have. I have a 3 and a 7 on this side. I want to get rid of that 7. It's being added, so it means I'm going to have to subtract. I got to do the opposite of addition. I'm going to do subtraction. Got to do it to the other side of the equation too. Got to keep it balanced. So 7 minus 7, there's going to be nothing there. I'm going to bring down this negative 3x. Negative 5, subtract 7. Remember, if you have a negative number and you're subtracting, your answer is going to go even more negative, okay? Think of it as 5 plus 7. We're going to get negative 12. Now, one more step to go. I need to undo this multiplication of negative 3, divide by a negative 3, and divide by negative 3. Negative 3 divided by negative 3, 1. 1 times x is x. Boom, we got x by itself right down there. Negative 12 divided by negative 3. When you take a negative and divide it by a negative, it's going to be positive. 12 divided by 3 is 4. Our answer, x equals 4. And that's a rundown of how you do two-step equations.